Hello, this is Mrs. Lewis with today's lesson on potential energy and work. Let's consider an elevator. The elevator is sitting on the ground. Let's say we go into the elevator and we push the button to go up. There would be some kind of a chain on the top of the elevator here, and that chain would exert a force equal to the weight of the elevator and its contents, because gravity is pulling the elevator down. And so if we have a force pulling the elevator up and these two forces are equal, then the elevator is going to move up with a constant velocity. The elevator is not accelerating, it's moving upward with a constant velocity, and the force pulling it upward is equal to the force of gravity pulling it downward. Now, when this happens, work is being done on the elevator. And this force, the force of the chain here, pulling it up, is going to do some work on the elevator. And we know that work equals the force, so this force times the displacement, however much the elevator moves upwards, and then times the cosine of 0 because the force is parallel to the direction that the elevator moves. So let's say this force here is 500 newtons. And let's say the elevator moved 10 meters. Then the work done would be 500 newtons times 10 meters times the cosine of 0, because the force is parallel to the direction of the movement, and so we would do 5,000 joules of work. When we do this work, we're going to change the energy of the elevator. And the work gives the elevator potential energy. The potential energy that the elevator gets when it rises up is exactly equal to the work done on it. So if we did 5,000 joules of work to move the elevator up 10 meters, then the elevator has a potential energy of 5,000 joules. They are exactly equal. If we pulled the elevator higher, if we pulled it 100 meters instead of 10 meters, we would get more potential energy, 10 times as much. If we had a heavier elevator, we would have to exert more force here to overcome the force of gravity, and then the elevator would get more energy. If we exerted twice as much force because the elevator was twice as heavy, we would get twice as much potential energy. Another formula for gravitational potential energy is mass times the acceleration of gravity times the height. So the weight of the elevator that we've been talking about is actually its mass times the acceleration of gravity. And we're going to use 10 meters per second for the acceleration of gravity. So let's suppose our elevator and its contents weighs or has a mass of 1,500 kilograms. And we're going to raise it 5 meters. Okay, so using this formula, the potential energy would equal 1,500 kilograms, the mass, times the acceleration of gravity, times the displacement. And that would be 75,000 joules. So that would be the amount of potential energy that this elevator has when it was raised 5 meters. Let's look at another situation. Supposing we have a car, and we're going to move that car, we're going to do some work to move that car to the top of this hill. Okay? And the car has a mass of 2,000 kilograms, and the hill is 16 meters high. So the potential energy would equal the mass 2,000 kilograms, times the acceleration of gravity, times the height, and when this car got to the top of the hill, it would have 320,000 joules of potential energy. The work we did put some energy in here, into the car. We changed the energy. Down here, the car had 0 potential energy. When we did work on it, it increased its potential energy. When it gets to the top of the hill, it has 320,000 more joules of energy than it had at the bottom of the hill. When we put the energy into the car, moving it to the top of the hill, its potential energy increases. Now, let's say the car goes down the hill. As it moves down, its potential energy is going to decrease. And when it gets to the bottom, its potential energy is going to be 0 again. Potential energy was 0 here. We did work. We increased the potential energy by putting energy in. Then the car rolled down. It decreased the potential energy down to 0 at the bottom. As the car goes down the hill, the potential energy decreases, but because of the pull of gravity, the speed of the car is getting faster and faster and faster, so it's getting kinetic energy, and as it goes faster and faster and faster, the kinetic energy increases. It gets to the very fastest at the bottom of the hill, where it has the greatest amount of kinetic energy, and when it has the greatest amount of kinetic energy, its potential energy is 0. So at the top of the hill, it has 320,000 joules of potential energy. At the bottom, it has 0 potential energy. But at the bottom of the hill, it's going the fastest, so that potential energy has turned into 320,000 joules of kinetic energy. Now, we know that the potential energy depends upon the height of the hill. So, what would happen if we doubled the height of the hill? Not here, but we push the car way up here. Okay, I hope you said that the potential energy would also double. Okay, the potential energy we know depends on the mass of the car. So instead of having this little green car, let's say the car was 3 times as massive. What would happen to the potential energy? I hope you thought that the potential energy would be 3 times as great. When we're talking about moving this car to the top of the hill, or taking the elevator and moving it upwards, we're talking about a kind of potential energy called gravitational potential energy. It has this potential to do work because if the elevator fell down, it would do work on something. If that elevator fell down, it would smash something at the bottom. The higher it was, the more energy it would have to smash something. So, in order to give the car or the elevator potential energy, we must do work. We have to do some work to move them upwards. And that work causes the energy to change. So, work is actually a change in energy. There are some other kinds of potential energy besides gravitational potential energy. For instance, when you pull back the string on a bow, or you take a rubber band and you stretch it, you give those two things elastic potential energy. And you change the amount of energy they have, and now they have some potential to do work. There's also energy in springs, and some springs get their energy. You can give them potential energy by stretching them, and then they have potential energy to go back to their original position and do work. Some of them get potential energy by compressing them, and then they have the energy to spring back to their original position to do work. So there are other kinds of potential energy, but we're going to mainly concentrate on gravitational potential energy.